Unsupervised and Supervised PCA Principal Component Analysis 4편의 첫 번째 동영상을 올리겠습니다. Supervised Principal Component Analysis, 줄여서 SPCA, using scoring. In SPCA using scoring, we compute the similarity of every features of data with the class levels, and then sort the features and remove the features having the least similarity with the levels. The larger the similarity of feature with the levels, the better the feature is for discrimination in the embedded subspace. Consider the training data D by N real matrix X up 위참자로 X1, X2, XD 트랜스포즈를 하죠. Xi는 D-dimensional 벡터고 Xj는 N-dimensional 벡터죠. Are the i's data point and the j's feature respectively. The type of SPCA is only for classification task, so we can consider dimensionality of labels to 1, 1입니다. 1. L equal 1. We have large Y, 1 by N matrix. We define Rn, n-dimensional vector, small y, or Y transpose. The score of the j's feature, X super J, n-dimensional vector. The super J는 XJ in the product의 크기 놈이요. XY in the product로 나타나죠. After computing the scores or the features, we sort features from largest to smallest score, like X prime, D by N denote the training data set whose features are sorted. We take the G equal to or less than D features with the largest scores and remove the other features. Let the Q by N X2 prime, X prime 요 중에서 1에서 Q까지 with the training data set with the Q best features. Then we apply PCA on X2 prime Q by N rather than the D by N X. Applying PCA and the counter PCA on X2 prime results in SPCA and the counter SPCA respectively. This type of SPCA was most used and popular in bioinformatics for genome data analysis. SPCA using HSIC. Hilbert-Smith independence criterion. Suppose we want to measure dependence of two random variables. Measuring the correlation between them is easier because the correlation is just a linear dependence. Two random variables are independent if and only if IFF. Any bounded continuous function of them are uncorrelated. Therefore, if we map the two random variables x and y to different separable reproducing corner Hilbert spaces RKHSS and have phi x and phi y, we can measure the correlation of phi x, phi y in a Hilbert space to have an estimation of the dependence of x and y in the original space. Hilbert space 다시 설명하면 real or complex inner product space that is also complete metric space with respect to the distance function induced by the inner product. The correlation of phi x and phi y can be computed by Hilbert-Smith theorem of cross covariance of them. Note that the square Hilbert-Smith norm of matrix A 이렇게 정의되죠. Trace A transpose A입니다. 여기 Hilbert space의 norm. The cross covariance matrix of two vectors x and y. cross covariance 두 vector cross covariance 이렇게 정의돼요. 그래서 여기 확률로 좀 꼽아놓은 거예요. Empirical estimation or Hilbert-Schmidt independence입니다. Criterion HSIC is introduced. HSIC trace 이 large KX2 프라임입니다. large KX2 prime, large KX2 prime, and KY are kernel over X and Y respectively. KX2 prime and phi X, phi X T, KY and phi Y, phi Y. Transpose입니다. We are using KX2 rather than KX because KX is going to be used in kernel SPCA. KX는 그냥 이렇게 써. in kernel SPCA. The term n minus u square 1 over n minus 1 square is used for normalization. The H is the centering matrix. HKH double centers the KY in HSIC. The HSIC equation 71 measures the dependence of two random variable vectors x and y. Note that HSE equals 0 and HSE equals less than 0 means that x and y are independent and dependent or independent or independent respectively. The greater HSRC, the greater dependence they have. Supervised SPCA는 두 번째 동영상에서 올리도록 하겠습니다.